got interested in the sciences ever since a young age. My parents are very much big fans of being outdoors, so then all that exposure to nature really ignited my interest in biology. And as I got a little older, I wanted to really apply that knowledge so that I could eventually find a real job studying in the field of biology. So this is how I landed up in medical research. My parents actually immigrated to Canada from China when I was about 10 years old, and I did most of my schooling in Canada, all the way until the point where I was ready to pursue a serious research career. So that's when I came to New York and joined Mount Sinai as a postdoc fellow about 8 years ago. So the focus of my lab is to understand the interface between tissue regeneration and fibrosis. And the idea is that maybe there are mechanisms we can identify that we can then use to improve regeneration of different organs or at the same time reduce the amount of scarring, which is the fibrosis. We know that the fibrosis in different tissues is produced by fibroblasts. So we are actively looking at how the fibroblasts move around. So they first have to move to the areas of injury where they become activated and start to produce all the extracellular matrix that make up the fibrosis. So we are trying to understand what makes them get there, what makes them activate, what makes them deactivate, in order to ultimately manipulate them to reduce the amount of scarring or fibrosis in the tissue. So we essentially applied this technique that was developed to image the brain and neurons in the brain very deeply, called tissue clearing. And we apply a similar method to the liver, where we essentially strip away all the fat, which is blocking the light. So now the tissue becomes very see-through, and then we can label the cells we're interested in, which are the fibroblasts in the liver. So then by tracking where they are, we can actually try to manipulate their distribution. We identified a new class of genes in the fibroblast that has not been described before, and these are called axon guidance genes. This is a class of genes that are known to direct the establishment of the axons from neurons in the neural system. However, we found that in these fibroblasts, these genes could also direct how these cells move around in the liver. So by manipulating these genes, we hope we can actually redistribute these fibroblasts from these areas of injury where they're producing the scar back to areas of healthier tissue where we know they could actually promote regeneration. So the long-term goal is to treat liver diseases, especially to reduce fibrosis, but at the same time to improve regeneration in the liver. So this exceptional scholar work from IHER was instrumental for us to establish some of these proof of principle studies. It allowed me to actually take on a graduate student to pursue this line of studies. This pilot award was able to provide the funding that's necessary to pursue some of these unorthodox ideas that I think are high risk but also very high reward if successful.